I'm starting. So light is incident here. Then as the ejected electron will be ejected by this particular plate, negative plate. It's telling incident or negative plate. So as the electron ejected, so this negative plate or plate B will acquire, the charge on that will decrease because the electron will be ejected. So it's like a positive charge. So the net charge of plate B will decrease here. And these electrons will go and deposit on plate A. So the net charge of plate A will decrease here. So the charge on the plates will be decreasing. And look at the current constant. Current constant means here. So if you see that, so further what is doing is going to connect an ammeter. Here a constant current flows here. And how much it is? 10 to the power of minus 12 ampere. What do you mean the current constant? All the ejected. See, one K max is what? 1.5 electron volt. What about zero kinetic energy electron? A zero will be. And it's telling a constant current flows means what? The current flowing is a saturation. Or don't say saturation. All the ejected, all the because of the electrostatic field present. So who will make it? Who will accelerate this like a zero kinetic energy electron? So the electrostatic field will be in this direction. So even the zero kinetic energy electron also will experience a force. So it will accelerate. So therefore, all the electrons will reach the plate A due to E bar. All the photoelectrons reach reach the plate A. I think that's a major concept. So straight away, so you can, what was the earlier charge? I think we can calculate the earlier charge. Earlier charge is equal to potential difference is how much? V naught that was applied, 10 volt. So Q should be equal to C into V naught. So we got the charge. Then what is the current flowing? I equal 10 to the power of minus 10 ampere. So therefore this current should be equal to I is equal to Q by T. So now we know the current, we know the charge, substitute here, we'll get the T. This is initial charge. I'll put it so that'll be easy for you. So this is that particular, what is the time? T1. So finally what will happen? After that what will happen? The charge, the current start decreasing. So what will happen is the charge will become zero finally here. This is what happens here. So on what basis you can say here? Say once what will happen as the charge deposition on the plate A keeps on increases, electrons get deposited, the number of electrons on the plate A increases, then the potential difference here will decrease. And at one instant what happen? The charge on the plate A will become zero, charge on plate B will also become zero. Then the fresh ejected electrons, so what they do? They will introduce a positive charge on this plate, negative charge on this. Why do this happens? Because of incident photons. As due to photoelectric effect, the electrons will be ejected. So this will acquire a positive charge. And how do it will set up field? Now it will set up a field like this. Is it all the electrons can now they reach? Earlier, this electrostatic field due to charge of capacitor was supporting for the all zero kinetic energy electron also to move from plate B to A. Now what will happen? Now what will happen? Here the ejected K max what when S it is having energy, it will try to move. What about the zero kinetic energy electron? In what direction will experience a force? Look at the electrostatic force which I am showing here now. The electrostatic force here acting will be towards right, so it will retard. So zero kinetic energy electron cannot reach here. So with the time, what will happen to amount of charge here? More number of electrons will be ejected, and Kmax electrons will go and deposit here. So charge on plate A will increase. Then the charge on plate B also will increase. So electric field strength will increase. Then gradually, what will happen? Along with the zero kinetic energy, those with non-zero kinetic energy electrons also stop reaching the plate A, and finally it will become zero. That's what he mean to say here, according to the graph. Now, why the curve should be like this? Why not straight, sir? Why you are putting like that? Because these electrons practically, so or so what will happen to the continuously what happen Kmax? It's not that only initially Kmax contingent electrons will be ejected here. And these electrons open when they come, there's some repulsive force between that also will occur. Due to that, the curve is not linear. Why do the curve is fluctuating here like this, some sort of sign? Because of the repulsive force between the electrons also. Those electrons which is about to reach here, other electron open which is moving may collide. So because of that, collision between electrons and also the repulsive force between them will make the current to fluctuate. This is what I think it's beyond our level to prove this particular graph. Just I'm giving explanation. So finally, what will happen? The ejected kinetic electron is its energy will not be sufficient to reach particular thing. So can we calculate that? So what is that? Kmax should be equal to Kmax should be equal to E into. So let me call this is V dash. So we know Kmax. We'll get that V dash here. So now, what is the magnitude of potential difference between the plates at time T1 and at time T greater than T2? I think we can work out from this. Numerical value of T1 is this one initially. From here, you have to bring it. Now, what is the magnitude of at T1? What is the potential difference at T1? Potential difference PD across capacitor is 0. Now, V dash will be non-zero. Okay. Anything? I think one more left over. Now, this is, I think, directly go for the saturation current depends on what efficiency. IH, the saturation current formula. Quantum efficiency, intensity, area, IA lambda by SC. Is that okay? So this will be the saturation current formula. So how to calculate efficiency, and he has given that